Good day, guys. Today I'm going to discuss to you about the chapter 13, which is the LAN configuration. So let's start. The wireless router. This wireless router typically provide WLAN security, which is the DHCP services, integrated name address translation or NAT, quality of service QoS, as well as the variety of the other features. The features set in the vary based on the router model. Log into the wireless router. To gain the access of wireless router configure GUI, open the browser. In the first add field, enter the default IP address for your wireless router. The default IP address can be found in the documentation that came with a wireless router you can search in the internet. The figure shown the IPv4, which is the 192.168.0.1, which is the common default for many manufacturers. A security window prompts in the authorization to access the router GUI. The word admin in the commonly used as the default username and password again. Check your wireless router documentation or search in the internet. These are the basic network setup. Log in into the router from the web browser. Change the default administrative password. Log into the new administrative password. Change the default DHCP IPv4 address. Create a new IP address. Log into the router with the new IP address. Next. Basic wireless setup. View LAN defaults. Change the network mode. Configure the SSID. Configure the channel. Configure the security mode. Configure the passphrase. Configure a wireless mesh network. Extending a WLAN in a small office or home has become increasing easier. Manufacturer made creating wireless mesh network WMN simple through the smartphone app. You buy a system, disappears the access point and plug in the download app, configured your WMN in a few steps. Search the internet for a Wi-Fi mesh network system to find the review offering system. Okay, next. Not for IPv4. The 2091.65.201.11, the IPv4 address is publicly routable on the internet. Any address with the 10 in the first octet is privately IPv4 address and cannot be routed on the internet. Therefore, the router will use process called network address translation or NAT. NAT stands for the network address translation for information. To convert private IPv4 addresses to internet routable IPv4 addresses, the process is reversed for the incoming packets. The router is able to translate many internal IPv4 addresses into public addresses by using NAT, the network address translation. Quality of service. The figure of the simplified mock-up of QoS interface based on the NetGuard GUI, you will usually find the QoS setting in the advanced menu. If your wireless router available, investigate the QoS setting. Sometimes this might be listed under the bandwidth control or something similar. Consult the wireless router, connect documentation, or search for the internet for QoS setting for your router make model. Port forwarding. Port triggering allows the router to temporarily forward data through the inbound ports of the specific devices. You can use port triggering forward data. Computer only in designated port range is used to make outbound requests. For the example of video game, might use 27,000 to 27,100 for the connecting with the other players. So that is the range for the connecting players for the games. These are the trigger ports. A chat client might use 56 for the connecting the same players so they can interact with each other. So that's the reason of port forwarding. What is WC topology? Labs use the Lightweight Access Control or LWAPP to communicate with the LAN controller or WLC. Controller-based AP are useful to situations where many APs are required in the network. As more AP added, each AP is automatically configured and managed by the WLC rather. Like into the WLC, the network summary page is dashboard that provides a quick view of the number of the configured wireless router, associated access points (APS), and active client. You can also see the number of RUG accent points and clients as shown in the figure. View app information. The AP using IP address 1.192.168.200.3 because Cisco Discovery Protocol or CDP is active on this network. The WLC knows that the AP is connected to the fast internet 0-1 on the switch. This AP topology is a Cisco AirNet 1815i, which means you can use the command line in the limited set of familiar iOS commands. Advanced setting. WLC will come to the basic setting of the menus that user can quickly access, implement variety of the common configuration. However, as a network administration, you will typically access the advanced setting. For the Cisco 3504, the wireless controller, click Advanced in the upper right and hand corner of the access, the summary page as shown in the figure. From here, you can access the feature of WLC. Configure a LAN. Which wireless LAN controller have a ports and interfaces ports are sockets for the physical connection to the wireless network. The resemble of switch port interface are virtual. They create software are very similar to the VLAN interfaces. In fact, each interface that will carry traffic from the VLAN is configured on the WLC as the different VLAN. The Cisco 3504 WC can support 150 access points, and 409 VLANs, however, it has a 5 physical ports as shown in the figure. It means physically port can support many APs and WLANs. The ports on the WLC are essentially trunk ports that carry traffic from multiple VLANs to the switch. For the multiple APs, each AP can support the multiple WLANs. SNP and radius. SNP is used to monitor the network. The network administration wants the WLC to forward the SNP lag messages, called traps, to the SMP server. The credential will be verified by the radius server. This way, individual user access can be tracked and audited. If necessary, and user account can be added or modified from the central location. The radius server is required for WLANs that are using WPA Enterprise Authentication. Configure SNP server information. Click Management tab to access the Variety Management feature. SNP is listed at the top of the menu on the left. Click SNP to expand the submenus and click the Trap Receiver. Click New to configure a SNP trap receiver. Enter SNP community name and IP address or IPv4 or IPv6 from the SMP server. Click Apply. The WLC will forward SMP lag messages to the SMP server. Configure radius server information. 1. Click Security tab. Next, the radius, you will see it, and then Authentication. No radius server are currently configured. Click New to add the PCA as the radius server and click New. Enter IPv4 address the PCA shared secret. This PCA is the PC1. This is the password used to the WC on the radius server is not user. Click Apply and shown in the figure. After clicking Apply, you list the configure radius authentication server, refresh, web, and server listed as shown in the table. Next, configure a network interface. Here are the steps in the creating the network interface. 1. Create interface. 2. Configure a LAN valid VLAN name and VLAN ID. Configure the port interface address. Configure the DHCP server address. Apply confirm and verifies the interfaces. Next, configure a DHCP scope. Review the topology. Explain the role of the WLC DHCP server. Create a DHCP scope. That is the steps for the configuring a network interface and the configuring of the DHCP scope. Configure a WPA Enterprise WLAN. Here are the steps. Review the topology. Create a LAN. Configure WAC to use the Radius server. Secure the new LAN with WPA2 Enterprise. Lastly, verify WPA2 Enterprise security. So,